So in this video, we're going to look at powers with negative exponents. So in the last video, we looked at powers with fractional exponents, which were a little bit different than anything we had seen before. And now we're going to look at fractions with negative exponents. And you might have kind of bumped into them every once in a while, but you didn't need to take a good look at what was happening, or even kind of really know why you were getting the numbers you needed to get. But it's good for us to look back now at a grade 9 power law to help us figure out what's going on with negative exponents. So here's a problem that you would have seen in grade 9. You have 4 to the power of 5 divided by 4 to the power of 3. And hopefully you know what to do with this, how to get there, kind of quicker. But we're going to do it kind of the long way first. We're going to kind of show this in expanded form first. So 4 to the power of 5 is 4 times 4 times 4 times, well, I don't know, 4 5 times. Okay, make them not so blurry 4s. All right, over 4 times 4 times 4. And the really fun part of grade 9 power laws was you get to kind of cross things out. So 4 divided by 4 makes 1. Okay, and another 4 divided by 4 makes 1. And another 4 divided by 4 makes 1. So we're left with 4 times 4, which written as an exponent is 4 to the power of 2. And then eventually we figured out that this kind of works over and over and over and over again. And so what we can do is we can just subtract exponents. So 4 to the power of 5 divided by 4 to the power of 3 became 4 to the power of 5 minus 3, which was 4 squared. All right, so what we want to do is kind of just use what we know already to be true and see what happens when I give you 4 to the power of 3 divided by 4 to the power of 5. Okay, so we should be able to do 4 to the power of 3 minus 5, which gives us 4 to the power of negative 2. And it seems reasonable. It follows a rule that we know to be true, and it works. It always works for us. But the reason why you didn't encounter these guys in grade 9 is because we're not supposed to leave fractions, or sorry, we're not supposed to leave powers with negative exponents. So there's kind of a law in grade 10 math, or in math in high school, that says we can't leave negative exponents in our final answer. Okay, so we actually can't leave an answer as 4 to the power of negative 2. We have to kind of go a step further. So what is that step? Well, let's go back to our grade 9 strategy to figure it out. So 4 to the power of 3 is 4 times 4 times 4. And 4 to the power of 5 is 4 5 times. And we make 1s. 4 divided by 4 is 1. 4 divided by 4 is 1, 4 divided by 4 is 1, and what we're left with is no 4's in the numerator. We just have that 1 that we created over and over and over again, and we have 4 times 4 in the denominator, or 1 over 4 squared. So if 4 to the power of 3 divided by 4 to the power of 5 is 4 to the power of negative 2, and 4 to the power of 3 divided by 4 to the power of 5 is 1 over 4 squared, then that means that 4 to the power of negative 2 equals 1 over 4 squared. Interesting. There is no negative exponent here. Yay. Okay, we didn't break the law. We've got a good answer here, right? That doesn't have any negative exponents in it and still follows what we know to be true about powers. All right, so what we want to do now is we want to figure out how we can do that kind of math a little bit shorter, right? Without having to write everything out kind of over and over and over again and cancel, and find a nice little kind of shortcut to take. So that's what we're going to do in these in the next page of our notes. Okay, so let's try to get it in focus. Powers with negative exponents. Okay, so you cannot leave a negative exponent in your final answer. Okay, so we can't do that. It's not kind of the right thing to do. I don't know why. I don't make the rules. I'm really sorry. I'm sure there's a very good reason for it, other than it's in our curriculum. But yeah, we can't leave negative exponents in our final answer. It's just not what we do. So what we do to deal with them is we flip the base and change the sign on the exponent. And if we were in class, I would make you say this over and over and over again, over and over and over and over and over again out loud, because there's a lot of, we can get a little confused on which thing we flip and what a sign gets changed, and it can get all very confusing if you don't kind of just stick it in your head. Exactly, we're going to flip the base and we're going to change the sign on the exponent, right? So think about what happened to that 4 to the power of negative 2 in our last question. The 4, right, what we did is we flipped the base. We did the reciprocal, right? It's really the reciprocal, right? So when we flip it, that's not a very math term, right? We're taking the reciprocal. And we did reciprocals. We looked at negative reciprocals when we looked at perpendicular slopes. So we've heard that word before. Okay, and then we're going to change the sign on the exponent only. That's the only sign that gets changed. And then that'll help us kind of get rid of that negative in our power that we don't want anymore. Okay, so let's evaluate. So remember, evaluate means get to the number. So the simplified number. Okay, so just tell me, how big is this? What is its actual value? Okay, so 3 to the power of negative 2 has a negative in the exponent. Again, we're not allowed to do that. It breaks the rules in powers. So what we want to do is we want to evaluate this by first dealing with that negative number. There's nothing else to simplify here. So we're going to take our base. What's the flip of 3, right? Remember that 3 and every number is always can be divided by 1, right? So that equals 3. So when I want to take the reciprocal of it, the reciprocal of 3 is 1 over 3. Okay, so I flipped the base, and now I just changed the sign on the exponent. The exponent was negative 2, now it's positive 2. And now I evaluate. 1 over 3 squared is 1 over 9. All right, question B looks a little bit tricky because we've got a negative in our base and we've got a negative in our exponent. So this is, a good place for us to kind of stop and think about, what does it mean? What does this mean? Flip the base, change the sign on the exponent. That's the only thing you do. And you know what? I even tried to turn it into something where we had to I tried to turn it into some kind of acronym. Sebesco or so, I don't know. It doesn't work. But if you can come up with a way of just kind of sticking that statement in your head, it'll help you kind of just deal with these negative exponents. Okay, so we're going to flip the base. The reciprocal of 3/4 is going to be 4 over 3, and it's a negative 3/4, so it's still a negative 4/3, right? We don't change the sign on the base. We only change the sign on the exponent. So now that we've flipped the base, our negative 3 exponent can become a positive 3. And now when I evaluate this, negative 4 to the power of 3 is 16 times 3 is 64, I think. Doing this video really late at night. It's, oh no, 16 times 4. Yeah, 64. Phew, that's good. And 3 to the power of 3 is 27. So this ends up being negative 64 over 27. Okay, so again, remember we only changed the sign on the exponent. Again, we've hit a decimal, so we always want to change decimals to fractions, right? Because we don't want to write something, we don't want to write the reciprocal of 0.3 as 1 over 0.3. Like we don't do that with fractions. We don't have decimals in the denominator of our fraction. So that just doesn't look right. So we want to change this 0.3 to 3/10 to the power of negative 4, right? And now it's really easy to flip our base. You know, the reciprocal of 3/10 is 10/3, and now we're to the power of positive 4. Well, 10 to the power of 4 is pretty easy. It's 1 with 4 zeros over it, or 4 zeros after it, and 3 to the power of 4 is 81. Okay, so we were able to evaluate that kind of crazy looking number really quickly without a calculator. All right, the last one, part D here, is again to help you remember that we want to flip the base and change the sign on the exponent only. Some students get really flip happy and they flip everything. We flip the base only. We take the reciprocal of the base only and we change the sign on the exponent only. Okay, so 8 to the power of negative 2/3, the base is 8, the reciprocal of 8 is 1 over 8. Okay, and then we change the sign on the exponent only so that negative 2/3 is now just positive 2/3. Notice we did not flip the exponent. Let's write a little note there. Don't flip the exponent. That's what this question is teaching us, right? It's just like this question up here was teaching us, don't change the sign on the base. Okay, so we do very specific things to very specific parts of our power when we have a negative exponent. All right, how do we evaluate this? We need our skills from the last lesson, right? When we have a fractional exponent, we think radicals, right? We're thinking about radicals. So we're going to take 1/8 becomes our radicand, 3 is our index, okay? And then we're going to raise this to the power of 2. All right, what's the cube root of 1/8? Well, cube root of 1 is 1. Cube root of 8 is 2. So we've got 1/2 squared, which is 1/4. Okay, so I hope these questions are actually, they're really, really representative of the kinds of things I want you to be able to do and the kinds of things I want you to watch out for when you're doing this work. Please let me know if you have any questions.